Welcome. Today, we will be diving into the world of SQL stored procedures. This is a fundamental concept for anyone working with databases. We will explore what stored procedures are, how to create them, and why they are so useful. So let's get started with creating and using stored procedures. Let's define what stored procedures are. A stored procedure is essentially a prepared SQL code that you can save and reuse repeatedly. Think of it as a function like in programming, but this function contains one or more SQL statements. These statements are used to access your database system. Now let's look at the key benefits of using stored procedures. First, they offer improved performance because the SQL code is precompiled and optimized. Secondly, they enhance security by reducing the risk of SQL injection. Thirdly, code reusability where you can use them again and again. Fourthly, it reduces network traffic since only the procedure name is sent over the network. Lastly, it makes the code easier to maintain by keeping the database logic in one place. Let's explore the basic syntax for creating stored procedures. Keep in mind that the exact syntax can vary slightly depending on the specific database system you are using, such as SQL Server or MySQL. Here is the basic syntax for SQL Server. Start with the create procedure keywords, followed by the name you want to give your stored procedure. Then, add the AS keyword, and inside the begin and END block, put all your SQL statements. For MySQL, here's the syntax. The key difference is that you need to add parentheses after the procedure name, even if the procedure doesn't take any parameters. Also, when creating stored procedures in MySQL, you might need to change delimiters so that MySQL correctly interprets the stored procedure definition. Delimiters are often changed when creating stored procedures in MySQL. Stored procedures become very powerful when you start using parameters. Parameters allow you to pass values into the procedure, making it more flexible. There are different types of parameters you can use. IN parameters are input parameters, which means you pass values into the procedure. This is the default type. Out parameters are output parameters. The procedure can return values through these parameters. INOUT parameters are both input and output. You can pass a value in, and the procedure can modify and return it. You can also set default values for parameters, so if a value isn't provided when the procedure is called, the default value will be used. Let's look at an example. Here we are creating a procedure called getEmployeesByDepartment that takes a department ID as an input parameter, which is an integer, and an optional HireDate parameter, which is of date type with the default value set to the 1st of January 2000. The procedure selects all columns from the employees table where the department ID matches the provided department ID, and the hire date is greater than or equal to the provided hire date. In short, the above SQL script is to fetch the details of employees from the employees table, filtering by department ID and hire date. Once you have created your stored procedure, you need to know how to execute it. The method for calling a stored procedure varies slightly between different database systems. Here's how you do it in SQL Server. There are two ways: using the execute keyword followed by the name of the procedure and the values for any parameters, or you can use exec shorthand followed by the procedure name and the parameter values with their names. In MySQL, to call a stored procedure, use the call keyword followed by the name of the procedure and the parameter values inside parentheses. When working with output parameters in MySQL, you need to use user-defined variables to capture the output. In short, output parameters in MySQL must be user-defined variables. Sometimes you need to change a stored procedure after you have created it. To modify a stored procedure, you use the alter procedure statement. This statement allows you to change the code inside the procedure while keeping the same name and parameters. The syntax is very similar to the create procedure statement. For example, if we want to modify the getEmployeesByDepartment procedure, we use alter procedure, specify the procedure name and parameters, and then include the modified SQL query inside the begin and END block. Now let's talk about deleting a stored procedure. To delete a stored procedure, you use the drop procedure statement followed by the name of the procedure. In MySQL, you can add if exists to avoid an error if the procedure doesn't exist. Error handling is a critical part of any robust stored procedure. Handling errors gracefully ensures that your database operations are reliable and that you can diagnose issues quickly. SQL Server uses a try-catch block to handle errors. The code that might cause an error is placed inside the try block, and if an error occurs, the control is passed to the catch block. Inside the catch block, you can use functions like error_number and error_message to get information about the error. MySQL handles errors differently. You can use declare continue handler to specify what should happen when an error occurs. In this example, if an SQL exception occurs, the exit handler flag is set to true, and an error message is returned. Transactions are essential for maintaining data integrity, especially when a stored procedure involves multiple steps. A transaction ensures that either all the steps are completed successfully or none of them are. In other words, it guarantees atomicity. Here's how you can use transactions in SQL Server. Start by declaring a try block. Inside the try block, begin a transaction using begin transaction. Then perform all your database operations. If everything is successful, commit the transaction using commit transaction. If any error occurs, the control will be passed to the catch block. Inside the catch block, roll back the transaction using rollback transaction. This will undo any changes made during the transaction. Finally, throw the exception to signal that an error occurred. Security is one of the most significant advantages of using stored procedures. They help protect your database from various threats and ensure that data access is controlled. Stored procedures limit direct table access, which means users don't need direct permissions on the tables. They only need permission to execute the stored procedure. This controls which operations users can perform, reducing the risk of SQL injection attacks. Stored procedures also separate database logic from application code, making it harder for attackers to exploit vulnerabilities. Finally, they enforce data access policies consistently across all applications that use the database. In SQL Server, you can grant execute permission to specific roles or users using the grant execute statement. Similarly, you can revoke execute permission using the revoke execute statement. To make the most of stored procedures, it's essential to follow best practices. These practices will help you write efficient, maintainable, and secure code. You should use meaningful procedure names, which makes it easier to understand what the procedure does. Add comments to document your code, which helps other developers understand your logic. Validate input parameters to prevent errors and security vulnerabilities. Include error handling to handle unexpected situations gracefully. Use transactions for related operations to ensure data integrity. Avoid excessive logic in procedures to keep them focused and efficient. Lastly, set appropriate permissions to control who can execute the procedures. Stored procedures improve performance by precompiling SQL code. They enhance security by limiting direct table access and reducing SQL injection risks. Parameters make procedures flexible and reusable. Error handling and transactions ensure data integrity. Proper naming and documentation aid maintenance. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.